and welcome to Teacher Nichols' channel. Today we'll be going over Algebra 2, Unit 2, Lesson 2. If you like these videos, please make sure to like and subscribe by clicking the button down here. And if you want personalized videos or tutoring, you can go ahead and find my Patreon in my bio, and you can sign up for personalized videos and tutoring if you'd like that as well. But let's get started. Problem number 1. Select all polynomials expressions that are equivalent to 6x to the 4th plus 4x to the 3rd minus 7x squared plus 5x plus 8. So immediately looking at this, I see that we have a 4th power, a 3rd power, a 2nd power, an x, and a variable with no exponent. And because the exponents are different, I know I cannot combine any of these answers, which immediately tells me this answer is incorrect. Let me double check that there's just E answers. Yep, so that answer is incorrect. So let's go ahead and look at the next one. 6x to the 5th. Well, we have no 5th power and we can't generate a 5th power from nowhere, so he's not an option either. 6x to the 4th matches our 6x to the 4th. 4x to the 3rd matches 7x, negative 7x squared, 5x, and 8. This guy's exactly the same, so yes, they are equivalent. Now for this guy, the 8 matches the 8. The 5x is positive 5x. This is positive 7x squared, whereas here we have a negative 7x squared, because it's a minus, so immediately, no. And then finally, we have our 8 matches our 8, our positive 5x matches our positive 5x, our negative 7x matches our negative 7x, our positive 4x cubed matches our positive 4x cubed, and our positive 6x to the 4th matches our positive 6x to the 4th. There we go, and we're done. Let's go on to the next question. As always, pause this video if you need more time to go over these questions as I move on to the next one. Problem number 2. Each year, a certain amount of money is deposited into an account which pays an annual interest rate of R. So we're talking about R. So that at the end of each year, the balance in the account is multiplied by a growth factor of X equals R plus 1. $500 is deposited at the start of the first year. An additional $200 is deposited at the start of the next year, and $600 at the start of the following year. Write an expression for the value of the account at the end of 3 years in terms of the growth factor X. So let's give us a little more space here. We want to write an expression of the growth factor at the end of the 3 years. So we need to make sure that we're thinking about each piece of this equation. So for $500 is deposited the first year. So let's write our function over here. Let's make this smaller and let's turn our pencil black. So we're going to say f of x is our function. We have $500. At the end of the first year, it's 500x. The next year, we're depositing $200, and he gets multiplied by a growth rate as well. But this 500, he got multiplied by a growth rate again. So instead of 500x, we have 500x times x. Finally, let's spread this out so we have a little bit more space. So at the end of the first year is 500x. The end of the second year, it's 500. This one gets multiplied, and this one. And the end of the final year, we have 600 multiplied by a growth rate. He got multiplied by a growth rate, and he got multiplied by a growth rate again, which gets us a final equation of 500 x cubed plus 200 x squared plus 600 x. And the reason it's a cubed is because he got multiplied by a growth rate 3 times over 3 years. He got multiplied by a growth rate 2 times over 2 years. And the 600 was the last year, so we only got multiplied by a growth rate once. What is the amount to the nearest cent in the account at the end of the years if the interest rate is 2%? So remember, x is equal to r1 plus r. X is equal to 1 plus r. So if r is 2%, x is going to equal to 1 plus 0.02, or x is equal to 1 plus 0.02. So we're going to go ahead and we're going to evaluate our expression right here. That's going to be 500 times 0.02 cubed plus 200 times 0.02, the decimal, cubed, time plus 600 times 1.02. We put that into a handy dandy calculator, calculate. My favorite calculator is NumWorks. I use it on my phone. Hopefully that's not backwards, but you can go ahead. It's free, it's online. The app is free as well. And I get 1350.68. And I am done. All right, let's go on to the next question. Problem number 3. Consider the polynomial function given by x cubed plus 8x squared minus 3x plus 1. Evaluate the function at x is negative 2. So we need to evaluate at x is negative 2, which means for every x, we're going to replace with a negative 2. Remember, I always put negatives in parentheses because that helps me keep track of the signs. Negative 2 cubed is negative 2 times negative 2, which is positive 4 times negative 2, which gets me negative 8. 5 times negative 8 plus 8 times positive 4. Negative and a negative is going to turn into a positive. 6 plus 1. We have negative 40 plus positive 32 plus 6 plus 1. 32 plus 6 is 38. 39. 39 plus negative 40 is going to be negative 1. And we're done. Problem number 4. An open box top is formed by cutting squares out of 5 by 7 inch piece of paper and folding up the sides. The volume V of x in cubic inches of this type of open top box is a function of the side length in x inches of the square cutouts and can be given by this expression. Rewrite this equation by expanding the polynomial. Well, I'm going to take this x and we're going to multiply him by those two. That's my first step. The V of x is going to equal 7 minus 2x times 5x minus 2x squared. That was step number 1. Now, I'm going to expand him, and I'm going to go over into this corner and use the box method. So you could use distribution, which is what I did for the x, or you could use the box method, which I'm going to use right over here, minus 2x squared. Remember to keep your signs next to the numbers in the box method. So 7 times 5 is 35x. 5x times negative 2 is negative 10x squared. Negative 2x squared times 7x is negative 14x squared. And this is going to be positive 4x to the third power. We're going to add all these guys together. Our biggest term first, 4x cubed. Our negative terms, a negative plus a negative is more negative, is negative 24x squared. And then our last term, plus 35x. And we are done. So you can use distribution or you could use the box method. Now, remembering that this x only gets distributed to one of these, think about if you're multiplying a number. If I said what's 2 times 3 times 4, first you're going to multiply 2 times 3, which is 6. And then you're going to say 6 times 4, which is 24. So here, I'm going to multiply this term by that term, get an answer, and then multiply that term by that term to get my final answer. So whenever I'm not sure about something which looks complicated, I always think, what would it look like if it was simpler? Because usually my intuition actually knows the answer to that question. All right, problem number 5. A rectangular playground space is to be fenced in using the walls of a daycare building for one side and 200 meters of fencing for the other 3 sides. The area, A of x, in square meters of the playground space is a function of the length x in meters of each of the sides perpendicular to the wall of the daycare building. What is the area of the daycare building when x equals 50? So let's start by zooming out so we have a little more space to work with. And let's draw this picture. I have not done this problem yet, so we're going to be doing it together. We have a rectangular playground fence, which is fenced in using the wall of the daycare. So here's our daycare right here. And then, well, let's think about it from above because we're thinking about it from above. And then we're going to have a fence that's going to be walled in like this. So 200 meters of fencing. So we're going to have this side plus this side, x plus question mark, x plus question mark is going to equal 200 meters. And of each side's, the area in square meters of the playground space is the function of the length x in meters of the sides perpendicular to the wall of the building. So when x is equal to 50, let's think about this. x is equal to 50. That means this is equal to 50. The whole thing is equal to 200. So this plus this is 100. So in this case, question mark is going to be 100 plus 50 plus 100 plus 50 gives you 200. What is the area? Well, the area is length times width, and that would be 50 times 100, and that would be 5,000, and we're talking about meters squared. We need to write an expression for a of x. Well, this side right here, when I did that first part of the question, I was like, I don't know this side, but I do know that 200 is equal to 2x plus, let's call it y. So y is going to equal always 200 minus x. So now we have that question mark or that y term in terms of x. So area of x is length times width. Our length is going to be 50, and our width is going to be 200 minus 2x. And that is going to be our expression. Finally, what is a reasonable domain for x in this context? So x could be 50, x could be 25, x could be 75. X could not be 200 or 100, because if x was 100, then we'd run out of all of our meters and we'd end up with a fence that looked like that. So what's the most reasonable kind of, I would say, let's just talk about what's possible in case you might want a 1 meter by a really long way. So I would say the domain x has to be in between or equal to, we're going to say greater than or equal to 0 because that's the smallest fence width that we could have. All the way up has to be less than, it has to be less than 100, because if it is 100, then it's 100 on both sides, and that's all of our fencing, period. So our domain, so x can be as small as 1 meter and all the way up to 100 meters in length, but it has to be greater than that, and that would be a reasonable domain. So we have to think about the context of the question for a question like that. Finally, problem number 6. Tyler finds an expression for v of x that gives the volume of an open top box in cubic inches in terms of the length x in inches of the squares cutouts used to make. So we're going to have cutouts like this, and we're going to fold it up, kind of yoop, yoop, and it's going to turn into a box. This is the graph that Tyler gets if he allows x to take on any value between -1 and 7. So this is going to turn into a box that looks kind of like this. And it's open top. What would be a more appropriate domain for Tyler to use instead? Well, x, you can't cut out a negative amount of space here. So it doesn't make sense that the domain starts at -1. So I would have my domain start at 0 and to be a little bit greater than 0, because you can't fold a box if you don't cut anything out of it. And then this graph over here shows me that the graph starts to do funky things right around 3.5. And what that's telling me is probably we've cut out more paper than we actually have, so it's not realistic. So I would say we would end this at 3.5, so less than or equal to 3.5. And that means we cut out 3.5 from either side. Probably, my guess is that this whole length was 7 inches, which is why that was his domain. And it starts to get really messy around 3.5 because that means we cut out squares so big that we basically have very little paper left to actually fold into that box. What is the approximate maximum value for this box? Well, if we cut out squares that are about 1.5 inches, then the maximum value, so this is the area of the length of the square that we cut out, and the maximum value falls out between 50 and 60, which is about 55. We're talking inches, our y-axis of volume, so it's cubed, so 55 inches cubed. If you like this video, please make sure to like and subscribe. Comment on them if you see any mistakes, because sometimes I make mistakes, and I'm looking forward to seeing you in the next one.